Okay, today we will learn about vertical motion. We have learned three formulas, that is V equal to U plus AT, S equal to UT plus half AT square and V square equal to U square plus 2AS, where V is final velocity, U is initial velocity and T is time, S is the displacement. So now we will apply these formulas in the study of vertical motion. Suppose this is ground, and from ground you are throwing a ball with initial speed u vertically upwards. Then it reach a height capital H and then stops. Stops means here the final velocity is 0, and again it falls back to the ground. So at the time of going upwards, if we apply these formulas, suppose the final velocity is 0, initial velocity is u, and the acceleration we know. Actually these equations are actually vector equations. Velocity is a vector, initial velocity is also a vector, acceleration is also a vector, time is a scalar. So this v and these vectors are suppose we take the vertically upward direction as positive y-axis, so we can say that this direction is j cap. J cap is the unit vector along y-axis. So this will be our initial velocity v vector, that will be 0 j cap plus equal to initial velocity u, this is also towards j cap, so u j cap plus a vector. The acceleration here, the only force acts on the ball is the gravitational force, and that is downwards, and this force equal to f vector equal to mg, but this is downward, so minus j cap, and so this will be minus g j cap t. So that means it will be 0 equal to u minus gt. So this t will be minus u by minus g, that is u by g. So the time it will take to reach the upmost point will be u by g. Now if I put it into this is also a vector equation, this is displacement vector. Now the displacement is h j cap equal to u vector u j cap into t plus half a vector is minus g j cap t square. So h equal to ut minus half g t square, but we know that value of t is here denoting the time it takes to reach to the upmost point. So the t will be equal to u by g, that means h will be equal to u into u by g minus half g into u square by g square. So this will be u square by g minus u square by 2g square, sorry, it will be 2g. So that means h will be equal to u square by 2g. So the height is, so if I throw a ball vertically upwards with initial speed u, that means the height it will reach as h equal to u square by 2g, and the time it will take to reach the upmost point, suppose it is, say it's capital T, and it will be your u by g. So we have to remember these things, because using this can be asked many MCQs. And similarly, now we will find that what when the ball is falling downwards. We know the time it takes to going upwards, but how much time it will take to bring back to the ground. So let's see. Now when it is the upmost point, suppose I am starting the motion uh, from this point to this point. So now I will take this v equal to 0 as my initial point, and this will be my final point. The ball is coming downwards now, so the initial velocity u will be now 0 j cap, because this velocity is still upwards, and now it will be falling down. So the v, the final velocity, I don't know, so we'll take as v. Plus a vector is always downwards, so this is minus g j cap and t. So v vector should be minus g t j cap, and we don't know this value of t. Now what about s vector? S vector, now the initial value is velocity is 0, so this u vector will be 0, so 0 j cap t plus half minus g j cap t square, so it will be minus half g t square j cap. And we know that s vector is, now if you measure displacement, this is your initial point and this is your final point, so the displacement will be minus h j cap. This is, you are this vector is from up to down, so this will be minus j cap, and the magnitude is h, we know, so minus h j cap, and h we found as u square by 2g, so this will be minus u square by 2g j cap equal to minus half g t square j cap. Implies that u square by 2g equal to half g t square. That means 2 will be omit, and u square by g square equal to t square. That means t equal to u by g. Time cannot be negative, so t will be u by g. So you see that the time it takes to reach the up point when it was going upwards, and the time it is taking to come downwards from the upmost point to the ground is same. So suppose, so that means t up equal to, suppose if you say this as t up, and if you say this time as t down, so t up will be equal to t down. That means the time it will take to reach upwards from ground to upmost point will be same when it is falling from upmost point to the ground. These two timings are same, so the total time t total will be t up plus t down. That means as these two are same, so it will be 2 into u by g, so 2u by g. So total time it is taking as 2u by g. Okay, now we will found what will be the final velocity v. V vector will be minus g, and the value of t here is u by g, so u by g j cap, g will be cut, and v vector will be minus u j cap. So our initial velocity when we threw the ball upwards, that was u j cap, and the when it is coming back, coming to the ground again, when it will hit the ground, the velocity will be minus u. That means magnitude will be same, but the direction will got changed. So it will again hit with u speed, but now the direction is opposite. And you can again verify that this equation, suppose if you are suppose if you take the initial position as this, when it was you threw the ball upwards, and final position as this when it brings back to the ground, then what is the time of flight? Then you can try to find that s vector is that neat displacement is 0 in that case, and then u vector, the initial velocity is u j cap, and t is the total time of flight, t total, plus half a vector is always minus g j cap, and t is here t total square. So this will be your minus u j cap t total equal to minus half g j cap t total square. Minus minus will be cut out, so it will be t total, and t total square will be t total, so it will be u by 2g equal to t total, and it is the same as you found individually. Sorry, it's not u by 2g, it will be 2u by g, and it's the same with what you got adding upwards separately, and then you found downward separately. You add the two timings and you got t total, and in this case you found the t total directly, taking this as your initial position, and when it brings back to the ground, taking it as the final condition. So here, from here you can verify that. Okay, thank you.